Hello students, welcome to another past paper discussion. Today we will discuss question paper 32 from winter 2014 exam. The discussion will only cover number 7 until 11. Now let's begin from number 7. Question number 7 is about wave. 7a. A police car siren emits sound wave that vary in pitch. Tick two boxes that apply to the sound waves emitted by the siren. Sound wave is a longitudinal wave. So, let's put one tick inside the box right next to the longitudinal. For the second box, remember, when a sound can be heard by human, it means that the sound is within the audible frequency. The car siren can be heard by human. It means that the car siren is within the audible frequency. Audible frequency range from 20 Hz until 20,000 Hz. So, the most appropriate frequency for the car siren is this one, from 100 until 10,000 Hz. It's still within the audible frequency range. These two boxes are the answer for number 7a. Now let's continue to question 7b. Figure 7.1 is a top view of one wavefront of a water wave before it strikes a hard boundary. Name the process that occurs as the wavefront strikes the boundary. When a wave strikes a hard boundary, the wave will be reflected. So, the answer is, the process is called reflection. Question 7b II. Explain, in terms of wave theory, what occurs as the wavefront strikes the boundary. As the wavefront strikes the boundary, new wavefronts will be generated. The new wavefronts will have the same speed as the wavefronts which strike the boundary. Question 7b III. State whether there is an increase, a decrease, or no change in the wavelength of the wave after it strikes the boundary. When the wavefronts strike the boundary, there will be no change to the wavelength because the speed and the frequency of the wavefronts stays the same. Next question. Question 7b IV. The speed of the wave is 3 meters per second and its wavelength 7 centimeters. Calculate the frequency of the wave. Before we start the calculation, first we have to convert the unit of the wavelength from centimeter into meter. So, 7 centimeter equals to 0.07 meter. Divide this by 100. Then you will get the wavelength in meter. Then, speed equals to wavelength times frequency. The speed is 3, the wavelength is 0.07 times frequency. So the frequency equals 3 over 0.07. The answer is 42 0.86 Hertz. We have to consider the number of significant figure used for our answer. This consists only one significant figure, and this one also consists of one significant figure. Usually, we can use one more significant figure than the number of significant figure used in the problem. So when the problem uses one significant figure, we can use up to 2 significant figure. So let's round this off into 43 Hertz. Write down the answer on the provided space. 43, don't forget the unit Hertz.